A scientific hypothesis can never be completely refuted by new information from an uncharted territory, no matter how solid or generally accepted it is. The James Webb Space Telescope, the most powerful telescope ever built, has yielded amazing views of the universe and, with 2 years of scientific investigations under its belt, has also shocked scientific minds with some unexpected and groundbreaking discoveries. One jaw-dropping moment at a time. We're going to explore the most revolutionary discoveries made by Webb today. The vast and mysterious world has a way of taking us by surprise when we least expect it. We considered ourselves to have a pretty good grasp of the universe when the James Webb Telescope first opened its infrared eyes. But the Webb didn't simply provide us with fresh photos. It also broke records, stretched the bounds of our knowledge, and forced us to reconsider everything from the nature of black holes to the birth of galaxies. Now, let's examine the top 10 findings that Webb has yet to share with us. Fasten your seatbelts, for what follows may completely alter the way we understand the cosmos. Imagine this. Prior to Webb's deployment in 2021, Z11 was the farthest distant galaxy known. Coming to us from more than 400 million years after the Big Bang, it was akin to our cosmic beacon. In the present day, Z11 has fallen back to the 11th position. James Webb has discovered the 10 new galaxies that hold records. The current champion is the galaxy Jade's Z13-0, whose light arose only 285 million years after the universe's formation. To put things into perspective, it has taken this galaxy's light more than 13 billion years to reach here. Picture yourself holding an image of the universe's early years, when it was still a newborn cosmos. Here's the twist, though. These far-off galaxies are not merely little specks of light. A few, such as Jade's Z13-0, are incredibly brilliant and span thousands of light years. It appears as though these early galaxies developed more quickly than we had anticipated. Is it possible that our current understanding of how galaxies evolve needs to be completely revised? Let's now move closer to home, to the star-forming Orion Nebula, which is located only 1,300 light-years away. Massive planets wandering freely without parent stars was something completely unexpected that James Webb's intense sight onto this well-known universe revealed. Even more perplexing, pairs of these road giants, known as jumbos or Jupiter-mass binary objects, accounted for about 9% of the total. Envision a scenario where 2 Jupiters just drift through space in unison, surpassing our present comprehension of planet creation. What is the frequency of this phenomenon? Do we yet know of a completely new class of planetary system? Things get much stranger from here on out. We have known for decades that the centers of the majority of galaxies contain supermassive black holes, which account for about 0.1% of the galaxy's total mass. However, Webb has discovered young galaxies with black holes up to 100% of the mass of their host galaxies, far too enormous for their age. It resembles discovering a kid hoisting a mature adult. The long-held belief that black holes slowly form from the remains of dead stars is upended by this revelation. Rather, it raises the possibility that certain enormous black holes originated directly from the collapse of vast gas clouds, which would fundamentally alter our theory of how galaxies develop. Similar to natural telescopes, gravitational lenses bend and amplify light from even farther away objects. With the discovery of a galaxy cluster 17 billion light-years away that bends light from objects behind it into an exact circle known as an Einstein ring, Webb has broken the record for the most distant gravitational lens. The worst part is that this discovery raises the possibility that Webb is still in search of farther-off lenses. Thanks to Webb, the great controversy in cosmology, the rate at which the universe is expanding, has further intensified. By utilizing its high-resolution capabilities, Webb was able to precisely resolve the brightness of individual stars in far-off galaxies, thereby eliminating earlier doubts. What was the outcome? It verifies that the expansion rate of the universe is around 74 kilometers per second per megaparsec, which is higher than the 67 kilometers per second per megaparsec estimated from the analysis of Big Bang remnants. This continuous Hubble tension compels us to reconsider some of our most basic beliefs on the nature of the universe. Our solar system, with its asteroid belt, Kuiper belt, outer gas giants, and inner rocky planets, was once thought to be a blueprint for other planetary systems. James Webb, however, completely disproved this theory with his discovery of the star Fomalhaut. Fomalhaut contains 3 belts instead of only 2, including a large intermediate belt that has no known counterpart in our own system. It's similar to learning that your standard model car has an additional engine you were unaware of. Are there possibly whole new kinds of planetary systems out there that have yet to be identified? Supernovae are the fireworks that light up the night sky if galaxies are the cities in the cosmic web. In an area of the sky barely bigger than an arm's-length grain of rice, Webb discovered 80 new early supernovas. We can now see into the chaotic early beginning, when the universe was only a few billion years old, thanks to this finding. A subset of these supernovas are standard candles, which may provide a more precise way to gauge the universe's expansion. Our preconceived notions about early galaxies have likewise been completely refuted by the Webb. It has long been believed that early galaxies were faint and tiny, gradually accumulating mass over billions of years. However, Webb discovered that a large number of big, bright, and heavy element-rich galaxies exist in the first 300 million years of the universe. It's like finding out that babies can bench press Olympic-level weights. Therefore, are we overlooking some fundamental physics that controls the development of galaxies in the early universe? We now have fresh perspectives on our heavenly garden because to Webb's observations of the solar system's intricacy are changing our understanding, from seeing plumes of water vapor erupting from Saturn's moon Enceladus to photographing the shadows created by the rings of tiny frozen worlds beyond Saturn. For instance, it showed that Jupiter's Great Red Spot is more than simply a huge storm. It's also creating unusual atmospheric gravity waves above it, which suggest dynamics we don't fully understand. And now for the real eye-opener. Potential evidence of life has been detected by Webb on a far-off exoplanet. In the habitable zone of its star, the planet K2-18b displayed chemicals like as water vapor, methane, and even dimethyl sulfide, which is only known to be created by earthly life. Even the most doubtful scientists should take notice of it, even though there isn't much hard data. The work of Webb is far from done. Cycle 3, which is about to begin, promises to further change our understanding of the universe with new targets and improved methodologies. Webb will keep expanding our understanding of the cosmos by conducting in-depth investigations of exoplanet atmospheres and looking into the oldest structures of the cosmic web. What comes next, then? Will Webb disprove even more of our assumptions, or will it find evidence to back up the hypotheses we now hold? There's no denying that the cosmos is far more intricate and unexpected than we could have ever anticipated. And we're only getting started because of the James Webb Space Telescope. Already, the James Webb Space Telescope has fundamentally changed our perception of the universe by upending our preconceptions and beyond the bounds of what we previously believed to be feasible. Webb is demonstrating to us the abundance of surprises in the universe, from altering the laws of galaxy formation to uncovering planets that float freely and even discovering possible evidence of extraterrestrial life. Every new finding provides answers to some of the most pressing concerns we have, but it also creates a wealth of unsolved mysteries. However, this is only the start. Who knows what revolutionary discoveries are around the bend in terms of Webb's next phase of exploration? There's no denying that the universe is considerably more active, intricate, and astounding than we could have ever imagined. So grab a seat and join us as we continue this amazing journey to discover the mysteries of the universe. Give us a thumbs up, subscribe if you haven't already, and click the bell to make sure you never miss an episode if this one thrilled you about the wonders of the cosmos. We continue to investigate the endless secrets of space, one discovery at a time, thanks to your support. I appreciate you viewing, and until we meet again, keep searching. Please let us know what you think. Give this episode a thumbs up and subscribe for more cosmic revelations. Our mission is to continue the exploration of the cosmos, one discovery at a time. I appreciate you watching, and I'll see you later.